Okay, today we'll take a look at the three trigonometric functions, and let's start where we left off last day, which was with a picture in a Cartesian plane. We had those x and y axes, and let's pick a point P and make a terminal arm that goes to P. And we actually know how far the coordinates are of P. We actually know the x and y coordinates, so this is x and in this direction is y, and we can think about that right-angled triangle in here. So if x is positive, if this x value on this point is positive, if that x value is positive, then we know that our point would have to be in quadrant 1 or in quadrant 4. If x were negative and it were over here somewhere, we know that that point would have to be in quadrant 2 or down here in quadrant 3. Likewise, x will be positive if the point is in quadrant 1 or quadrant 4. And let's take a look at y. Y is going to be positive if the point is in quadrant 1 or 2. And what about this r value? Well, when you take your x value and your y value and you square them and then take the square root, that r value will always be positive. Now let's start to put some of this patterning together with some definitions of the trigonometric functions. So the sine function is equivalent if you take the sine of an angle, and in this case we're using angle theta. Sine of angle theta is the opposite over the hypotenuse, sometimes shortened to op over hyp, or even shortened further to O over h. Cosine of the angle, short to cosine of the angle, is adjacent over hypotenuse, or adj over hyp as an abbreviation, or a over h. And the tangent of the angle, shortened to tan theta, is the opposite over the adjacent, or the letter O over A. And some of you may have even seen a shortcut to remembering these as the mnemonic SOHCAHTOA, sine opposite hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. But what I want to do is put this together as the definitions of opposite and hypotenuse for sine, along with what does it mean in terms of this picture above. So the opposite would be y and the hypotenuse would be r. So another way of thinking about sine is that it's the y value over the r value. For the cosine, it's adjacent over hypotenuse, which would be x over r. And for tangent, it would be opposite over adjacent, which is y over x. And these are the definitions that we're going to be using a lot more in this unit. So let's start by taking a look at these in a little more detail in combination with when are things positive and negative. So we said that this r value is always positive. Well, when would sine be positive and when would sine be negative? So if you think about the quadrants, if you're in the first quadrant, this y value will be positive. So sine of things in this quadrant will be positive. In the second quadrant, the y values are also positive. So sine of things are positive divided by a positive. Sine of angles will be positive. If you move down into quadrant 3, something a little bit different happens. Your sine value is now, well, your y values are negative, so it's a negative divided by a positive. So now your sine values are all negative. And how about in this last quadrant? Your sine values down here are also negative because the y value is negative. For cosine, we're going to do a similar thing with the x value. So over in quadrant 1 and quadrant 4, your cosine value of your angle is positive over positive. And same down here, it's a positive x value over a positive r value. And in this quadrant, cosine theta, which is a negative x value divided by positive, is negative. and same here. And you start to notice, like sine was positive in 2 quadrants, cosine was positive in 2 quadrants, which means sine is negative in 2 and cosine is negative in 2. Let's take a look at what happens with tangent. So in this quadrant, tangent theta, well, my x value and my y value, they're both positive, so it's positive over a positive, and that gives me a positive value for the entire fraction. In this quadrant, I'm going to get a negative x value and a positive y value. So positive and a negative is going to give me a negative. In this quadrant, I'm going to get a negative x value and a negative y value, and a negative divided by a negative is a positive. And in the last quadrant, I'm going to get a positive x value and a negative y value, so it'll be a negative over a positive, which will be negative. Let's be good mathematicians here and look and see if there's any patterns. So here I see some positives. Here's a positive. Here's a positive. And right there is a positive. Everywhere else there's negatives. And so one way to memorize or learn this system of when things are positive and when they are negative is through a little acronym. Notice here they're all positive. So I'll use the letter A to tell me which ones are positive. In fact, all of them are. In quadrant 2, the only one that's positive is sine. All the other ones are negative. Then in quadrant 3, it's tangent, and finally in quadrant 4, it's cosine. So A, and then S, and then T, and then C. ASTC is a nice little acronym to remind you, starting in quadrant 1, which of the trigonometric ratios are positive. You automatically will know, therefore, which ones are negative. I've heard some people say things like, all suckers take chemistry, or all students take calculus, as a nice little mnemonic to remember this quadrant rule for positive and negative values of these trigonometric ratios. Now that we know this, let's take a couple examples, or at least one example, and see if we can work with it. Okay, in this example I want to find tan theta, and that means find the ratio. Tan theta, remember, is y over x. Find that ratio if the sine ratio, so this is opposite over adjacent, is 1 over quarter. And we know also that theta, the angle, is in quadrant 2. So step 1 for me, always with these sorts of questions, is to draw a picture. For instance, I know that I'm in quadrant 2, so I'll just draw a terminal arm in quadrant 2. Here's my theta that I'm trying to figure out. And I know that sine theta in this quadrant is 1 quarter. So I use this little reference angle. The opposite will be 1, and the hypotenuse will be 4. That's from sine, opposite over hypotenuse. Ooh, I made a pretty big mistake there. Good thing I am catching it. This is, of course, opposite over hypotenuse. And so there's 1 over 4. And now, once I've drawn a picture of what I have, then my next thing is I need to use the Pythagorean theorem to find out my missing side, because I need to know this x value. I've got the y value so that I can find this tangent ratio. So I'm solving for x in the triangle 1x and 4. So I get 4 squared is 16, and 1 squared plus x squared. So 16 is 1 plus x squared. Subtract 1, that gives me 15. And then take the square root, and I get x is equal to the square root of 15. So I actually get plus or minus, but I know which quadrant I'm in, so this is the square root of 15, and I know that I'm in quadrant 2, which means that I know that I'm just dealing with x being negative root 15, and so now I can state my trig ratio. And sometimes I'll put ratios, because sometimes you're actually calculating more than one. So tangent theta, we know by ASTC that only sine is positive. Sine's 1/4, so sine's positive here. So we definitely know that this is going to be a negative answer. And then my fraction is my y value, so that's 1, and my x value, which is root 15, or this could be negative root 15, and then you wouldn't need this negative sign here. I just need to make sure this whole fraction is negative. So tangent in quadrant 2 is, of course, is negative. So state the missing ratios, use ASTC to get the appropriate sign. By sign I mean plus or minus, and we're done. Now you could simplify this a little bit. Tan theta could be equal to, and if you don't want root 15 on the bottom, you can multiply the top and bottom by the conjugate, and you'll end up getting negative root 15 over 15. That's a perfectly acceptable answer as well. Okay, we'll get a lot of practice with this in class. See you then.